All right, welcome back to another round of amazing API reviews. So last week I wasn't here, so I don't know what happened. I assume it went well. And so this week I think I just scheduled whatever was next in line. I skipped 2 items because I don't think they are really ready because nothing changed since last time. So I think Levi, this is yours, I believe.
I think actually Adam was going to talk about that, unless you want me to take it, Adam.
I can take it, but it would be nice to get some help from you when people disagree on the APIs that you have designed.
Okay.
So to tell the long story short, Levi has designed a set of APIs that are going to allow for high performance text operations for ASCII text, which is represented as either a buffer of characters or a buffer of bytes or both and mixed. So we have operations like equals, index of, starts with, ends with, get hash code, etc. The APIs have been discussed at least 2 or 3 times already. I have provided a list of previous conclusions. And now we have something that we believe is the final version of the APIs.
Final 2. So I guess this is the API.
Yep.
So what's the high-level design point? It's basically we don't have a dedicated type, right? We just have read-only span as byte, I guess, as the primary type, and then everything else is just effectively helper methods over that.
Yeah. So far, when you wanted to perform some text operations, for example, in networking, you would have to decode bytes into a string, which would take some time in memory. And you very often have a situation where you have a buffer of characters and a buffer of bytes, and you want to perform some operations. Ideally, as fast as possible without allocations. So these are quite low-level APIs focused only on ASCII. So very simple text operations. If I would really like to add something more to that.
Do they validate that it's valid ASCII?
It depends. So first of all, maybe let's start with something very simple. We have 4 methods that are called isASCII. 2 of them are for single values, a byte and a character. Then we have 2 for buffers of characters and bytes. These are very frequently used everywhere in the BCL. And then we have methods that are for comparison, like equals. And equals accepts, so equals does not throw when we find something that is non-ASCII. However, all other operations like index of, last index of, starts with, ends with, they throw when the so-called needle, which is here represented always as the second argument, contains non-ASCII characters.
But they're not throwing if haystack contains non-ASCII.
Yes.
Right, and the reason is that when we were talking with Steve Tobe and a few others, their scenario was that the haystack might just be, arbitrary network input, and say that you're implementing a protocol on top of this, and you want to know if, the incoming data begins with the word hello, because maybe you're implementing like some SMTP or POP3 server, whatever it is. You don't necessarily want to fail on incoming bad data. You just want to say, not a match, sorry.
Should we potentially call this extended ASCII to make it clear that it allows any quote-unquote ASCII input, and it will interpret it as a literal 255-byte character rather than as actual ASCII, which only goes between 0 and 127?
No, so if you read the description above all the APIs, ASCII, every single method here defines ASCII to be a 7-bit byte or character. Anything that has the 8 or higher bit set is non-ASCII, and depending on the API, it will throw or it will treat it as no match. There's no API in this entire surface that does opaque comparison of two non-ASCII values.
So what happens? So if you have, so if you're comparing two, so if we just call equals here between left and right, and either input has a extended ASCII character, just to simplify, then it will throw, or it will treat it as no match.
Correct. It will not attempt to do. So for example, say that it's attempting to do like say that the read-only span of byte on the left contains a value 255, and the read-only span of char on the right contains a value 255. They just happen to be different widths. That would not be treated as a match. It's not a simple widening operation. Like there is an actual RU ASCII in place in there.
So basically, if either side contains non-ASCII, then the return value is false.
Or it throws depending on the API.
Right.
That seems like really confusing behavior depending. Like you have to completely understand which one is which parameter is validated for correctness and which one is just compared like byte-wise.
The general answer is, and again, this is all described in the text, but the general answer is if the parameter is a needle, it's validated for correctness. If it's not a needle, then it's not validated, and it will just return false.
I understand it, but it also seems very confusing to me over just saying allow an extended ASCII range and basically treat it like most of the C APIs do for quote unquote ASCII.
But
So,
the problem
again,
with that
this
is the extended ASCII doesn't map to UTF-16 at all, because there are like 4 characters that are code point dependent, and then the rest of them you could map, but you can't say what those other 4 are.
So I also want to call out, like, there is ample description in the issue of this, and why this particular behavior was chosen, what alternatives were considered and rejected. Particularly the behavior, Tanner, that you had asked for, just widen it and treat it as opaque. That is Latin 1, not ASCII. And the reason that we had considered and rejected that is because if you use normal .NET APIs like encoding.ascii.getString, it will actually return a different result than these APIs would. And we don't want to introduce APIs across .NET, which, depending on how you call them, sometimes return true and sometimes return false, which is why these APIs are very eager to fail if you pass them data that's simply nonsensical. Again, like I do recommend reading through the thread on this to kind of understand why these behaviors were chosen. They were chosen to be a pit of success specifically, because we identified far too many scenarios where doing the simple thing was actually an anti-pattern.
The other question I have is why buffers? I feel like system buffers, like, okay, I own the namespace, but it is a namespace which no one can ever remember, no one ever finds the types on. It's basically not discoverable at all. Why not put these APIs on system text ASCII encoding and have people just use that where they're already going for other ASCII specific APIs?
That was also answered in the issue here, but general answer is that ASCII encoding, just like UTF-8 encoding, just like everything else, has opinionated fallback behavior and configurable fallback behavior based on how you instantiate it. These APIs would not honor any type of configuration that you use to instantiate the ASCII encoding. as a result, they have different behaviors than the rest of the ASCII encoding class, which means putting them on the same type would be very confusing.
I also don't think people actually look for ASCII encoding. What they do is they do encoding.ascii, and encoding.ascii returns a type called encoding, so it doesn't actually return ASCII encoding. So we don't really have a home for ASCII specific APIs that I think people would actually look for.
Right. So ASCII encoding, for instance, if given a string which contained a character 255 and a string which contained a character 254, ASCII encoding would actually say that they're the same, which is bad. And because our behaviors are very different than that, again, we don't want to conflate the APIs.
But why not static class ASCII in system.txt? Like, why buffers?
I don't necessarily care for this.
Yeah. My main concern with buffers is it's the namespace where someone asks for something and then I go and say, look at this thing in system buffers, and they're like, system buffers exists? And that happens like too many times a year for me to keep track of. No one ever remembers it. We've got all those APIs on like binary primitives under buffers, and everyone's like, why isn't this just on bit converter? And I have to explain because net standard. Like, I really wish we didn't have buffers and we moved all this stuff elsewhere instead, because no one can ever find them. And that's my concern on us exposing these APIs in buffers, is it's just going to be more of no one knows where they are or how to get to them.
I mean, it kind of also depends on who the target audience is. So I guess this is a fairly narrow target audience, right? Or are you suggesting, Levi, that people use this type over encoding.ascii or ASCII encoding?
This would be primarily for people doing like protocol development, I think. I don't expect the typical developer to use these APIs.
For what it's worth, right? Like Kestrel uses the encoding APIs a lot. We started like requiring that headers, like request headers, are ASCII, because that's what the spec says. But then people send UTF-8 all the time, so we supported that. And then there's an option even for Latin 1, which is of course incompatible with UTF-8. But like Bing uses that because it's basically a way to shove a byte array into a UTF-16 string when you do that conversion. Like, you basically don't lose anything. So then that allows Bing to just interpret the header encoding however they want. I'm not sure if we'd use it. Like, normally, like, I mean, maybe we would. So like normally we'd use sequence equals and stuff, and then just like if we really want to verify it's ASCII, do some SIMD check to make sure no high bits are set or whatever.
Yeah, the APIs that Adam will talk about later, I think, would be more interesting to Kestrel, because there are higher order operations like hash code calculation.
Oh yeah,
So-
we probably would use that.
So just to, so return for a moment to the exception model, the example you gave of you want to know if it starts with the ASCII string hello, like that's fine and completely sensible. The interesting one is when you get index of, where if the haystack, if it walks past a bunch of non-7-bit ASCII characters, does it make sense to say that yes, it found the ASCII hello in the middle? And if we think yes, then sure, but you've asked an ASCII question of non-ASCII data and gotten a hit. So if we're content with that, as for index of, where it could have walked past garbage data, then sure. But that's the starts with and ends with both have the I didn't have to consider invalid data along the way.
So think of it this way. For starts with, the haystack is read-only span of byte binary data, and the needle is read-only span of ASCII byte text data. It's looking for the existence of text data within binary data. So it's okay if it's prefixed with absolute garbage. It just gets skipped.
Fair enough. Just
It is
asking the
a
question
good
to make
question,
sure
though.
that it's thought of and known, and when we write this, that we have tests that explicitly put garbage on both sides when asking index of and prove that we don't care about it, etc.
Yeah, and again, this was to support the scenario where like you have some kind of data coming in from the network. You don't necessarily know what's in front of it, what's after it, but you want to do a sub pattern match inside of it. This
Sure.
In large part, the confusion I think stems from the fact that like we're using read-only span of byte to represent absolutely everything. Like it could be random binary data, it could be ASCII data, like ASCII text, it could be anything. So the APIs kind of on a per parameter basis need to talk about how that sequence is interpreted.
Fair enough. So
This is why we should
You're
have
saying that-
exposed car 8.
well, in this case, it would be car 7. That it would
Yeah.
be needle is car 7 and haystack is byte.
Exactly, yeah.
I don't think we would have ever exposed a car 7. Not even C does that.
Well, we have to distinguish it from the UTF-8, whatever it calls bytes.
Yeah, the
It's not a
interesting
code
thing.
unit.
Yeah, the interesting thing there is like for ASCII UTF-8, like call it char x whatever. It's this sequence of it that you care about because the sequence has to be interpreted in a specific fashion. But that's it. Anyway, been talking over Adams.
Yeah, so I just wanted to add that Levi has already implemented a few of these methods, and I have implemented the rest of them and even found some usages across BCL. And very common operations is checking if given buffer contains any non-ASCII characters, then performing to lower or to upper. That's frequent in networking, at least in a few places. And then we have comparing two buffers of different types, namely characters and bytes for equals ignore case comparison. And then comes the encoding and decoding.
Right. Should we just walk them top to bottom so we can just review them all? Or did we already review them and now it's just there's a delta towards what we did last time?
Most likely delta would be the most efficient way, at least from my perspective, but
Do you know what the delta is? Because I don't actually remember.
if you give me 1 minute, I can create it very quickly.
That was February, yeah, that's why I don't remember anything.
Yeah, while Adam's creating that, some of the methods became try methods. For instance, hash code calculation. And there were tweaks to the shapes of other methods based on API review feedback from last time.
Just asking the question, the non-try get hash code methods obviously throw on invalid data. Okay.
What do they throw? Format exception?
I would imagine argument exception.
exception.
Argument exception.
Yeah, format exception is supposed to be that you have an invalid format string or your parse and the input couldn't be parsed.
for like single character operations, like say I want to do index of I don't know, some single character. Have we thought about that at all? Or does it not matter because I would just do index of?
I think with .NET 7, it's not the cleanest thing, but you can at least do new read-only span in, and then cast to byte quote character, or just new read-only span. You don't use the in keyword in that case since it's a R value.
Well, if you're looking for, if you have a single character needle, I would imagine you would just use a normal index of extension method.
Because we're not doing any validation on the haystack. We're skipping over invalid bytes.
Correct.
Which is what the normal index of would do.
Well, remember, the normal index of is just a straight up binary operation or binary comparison, unless you specify a different comparator.
And what's the difference here?
I believe the index of methods here also do case comparison.
Okay, so if I wanted to do index of ignore case with a single A.
Okay, so index of that does case comparison. The haystack here is text. What happens when one of those characters is 255?
It skips it.
No, it throws an exception. For the needle, correct?
No, for the haystack. The haystack is text.
Yeah. Okay.
So you're doing index of in the text for a case sensitive comparison.
It's ignored.
So we silently say this character doesn't exist, and so it must not have an uppercase form.
Correct. So it's again while Adam's getting all of that ready. In the text, I talk about transformations of ASCII text. If you're doing a regular index of, the transformation is an identity transformation. All ASCII transformations, by definition, have an ASCII domain and an ASCII range. If you encounter a non-ASCII byte in the haystack, by definition, like no ASCII transformation could have resulted in that, which means it can be safely ignored because no part of the needle ever could match it. If you have non-ASCII data within the needle itself, we don't know how to transform it and we must fail. Think of it as building up a whole bunch of index of innies under the covers. And when we see data within the needle that we don't understand, we don't know what index of any to pass into the search. So we have to fail at that point. But beyond that, the search is just pure binary equivalence, which is why the haystack can contain non-ASCII data. Again, haystack is binary, needle is text.
If it's taking this long to get the diff, it seems like it might just be easier to just go over what the actual proposal is.
Sorry, I was muted. Don't you mean text is the haystack and value is the needle because we're searching for value in text?
The haystack can be any arbitrary binary data because it's the thing being searched within. The needle has to be actual ASCII text because it's the thing you're searching for.
Right, and so text can be anything, but value has to be ASCII.
Correct.
So, given that you keep saying that the haystack is not text, it's binary, maybe it should not be called text.
Sure. It's the same argument names we use for other overloads, but yeah. No, I'm
Well, I mean,
using during this
within this class.
discussion. Yeah, during this review, I'm using the term haystack and needle because it's more technically accurate.
Right. Just, that maybe it should be, instead of text, source, that you're searching this source.
Sure. I mean, we could also just start using the actual
Data.
terms haystack and needle.
I feel like we have in some places.
I don't think we've used it in any public API service, and I'd be worried that the idiom "needle in a haystack" is confusing to non-native English-speaking users.
Fair enough.
I think source and value is potentially much less confusing. Although I think users are going to get confused regardless on one of them not being validated, the other being validated.
I don't think that's going to be a huge issue in practice because, like, the common scenario is going to be people searching for literals.
Yeah, but UTF-8 literals can be lots of stuff.
They can be, and if you're searching for something that contains non-ASCII here, so because it's UTF-8, for instance, it actually behooves us to do that check for you and make sure that you're not actually including any non-ASCII characters in the needle, because the match would be incorrect at that point, even if we return true.
Yeah, I was wrong. We don't have needle or haystack as a parameter in anything public.
Yeah, I agree with Tanner on the idiom doesn't translate very well.
Okay, that's a fair point.
But equally, I don't like left and right, because to me, left and right usually means they're treated the same when it comes to validation. At least that's what I would expect.
Correct. For things like equals, left and right are used because they are effectively interchangeable. For whenever we have a needle and haystack concept, they're not left and right because one parameter is in fact treated differently than the other. By the way, the text that's on the screen right now was an early prototype. Sorry, the earlier API review. So the textual comments with that are incorrect. They're not what we're actually reviewing today.
Sorry, I was scrolling back earlier. I forgot about it.
Yeah, so the text comments here accurately reflect the proposal, the behaviors that are proposed. So, for instance, the comment above index of clearly says throws an exception if the needle contains not ASCII data. Which again makes sense because if you're using like a UTF-8 literal and you're calling an ASCII API, something's probably very, very wrong on the call site.
I expect most people will use UTF-8 literals because it's significantly simpler and easier to read.
I meant if you have non-ASCII UTF-8 data within the literal is what I should have said.
Okay.
But yes, but yeah, I agree. Most people would use the literals because they're easier.
Which is also why I think failing for if value contains non-ASCII data makes sense, right? Because that would probably suggest that the user wrote the wrong code.
Correct. You probably wanted an actual an actual index of or a UTF-8 specific API or something.
Right.
That's also, by the way, why we can never really do Latin 1 equivalents of these APIs, because once you have the UTF-8 literal syntax and you're trying to pass it to a Latin 1 API, what on earth happens? They actually encode the underlying data differently.
How's your diff coming, Adam?
I have already posted something on GitHub, so we can start the discussion. In the meantime, I will be just editing it. It's like
oh, perfect.
It's Plenty of methods.
Yeah, I tried it earlier and I gave up because I didn't know how to reorder them in a meaningful way. All right, so let's start with equals then. So basically you removed all the combinatorics and you just left with the span and char one.
Yes, because these particular methods, they don't throw when they find non-ASCII character. So we have already things that can do it for us, like memorial extensions, sequence equals to, sequence equals, etc. So the only one that we are missing is the possibility to compare characters and bytes. And the other change is changing a method that was accepting a string to a method that accepts a read-only span of characters, so people don't have to allocate.
So you wouldn't expect somebody to wanting to compare raw bytes with a UTF-8 literal then? You have to have a string literal?
A U8 is a read-only span of byte.
Yeah, but
that will be
for
on the
that-
right-hand side, right? Presumably your left-hand side would be whatever data you have from the wire, and then you would put the literal on the right-hand side, which right now would only be a string literal because that's the only thing that you can convert to read-only span of char, right? So if you want to use UTF-8 literal, then you would have to have an overload of equals that takes raw byte and raw byte on the right-hand side, right?
Presumably, you would just use sequence equal at that point.
Yeah.
I mean,
Yeah,
I'm
I
think it's
okay
how
with that,
how
but
much
that seems
duplication do we
weird.
want?
Yeah.
Right, because the only thing that the ASCII.equals of ROS byte would do is either just be sequence equals, or it's going to validate that everything was equal and everything was ASCII.
Yeah, and then you end up with a weird difference in behavior with the byte-byte overload versus the byte-char overload, because the byte-char overload right now can return false if it sees non-ASCII data anywhere, because it simply doesn't know how to do the conversion. If you have a byte-byte overload, would it return false even if the data is identical?
Yeah.
Like,
I mean,
that just seems really ambiguous at that point, and you may as well just use sequence equal, because the ambiguity is completely avoided. It's just a straight up binary comparison.
I'm not sure I understand. Like, don't you have the exact same problem for every other cases where you allow a ROS byte for the needle?
Equals is not a haystack and needle. That's the interesting part about it.
Yes, I get that, but then like you're saying it would be weird to return false if the right-hand side would return non-ASCII characters, but is of the same shape as the left-hand side. Why do you think that's weird? To me, that's not any weirder than saying if I give you a ROS byte needle and you return false if it doesn't contain non-ASCII data, why is that any different?
It doesn't return false, it throws for the needle APIs. So what's interesting here is the APIs that take a needle in a haystack will throw if the needle can't be understood, because we simply don't know what to do with it. Equals is not a needle in haystack. Equals takes two peers effectively and tries to compare them, which means that the ROS byte and the ROS char overloads, because they have to perform a conversion back and forth one way or the other, they're able to get away with returning false if any of the data is non-ASCII, because like we can't simply widen this and do a comparison because it's not Latin 1. However, if you have byte-byte or char-char, like people might reasonably expect us to do a straight-up binary comparison.
Yeah,
but we already have APIs for that. Like, what value would we be adding?
But that's exactly why I think it would be weird to expect that. If you call ASCII.equals and you have non-ASCII characters, I think it's reasonable to say we gave you false. If you actually wanted a byte comparison, then call the regular sequence equal one, right?
Even if you pass the exact same buffer for both inputs?
Yeah, if they're not valid ASCII, yeah. I think that's reasonable.
Now we have, so the entire thing that this was trying to avoid is where you have some .NET APIs returning true, like sequence equal, and some .NET APIs returning false, like ASCII.equals. We don't necessarily want to end up with this difference in behavior where depending on what API you call, you get an actual different Boolean result. That's why the needle and haystack APIs were eager to throw if they couldn't answer that sanely. Because then you don't get a result, you just fail.
Yeah,
Like
but
if we,
but do you but like just to throw this out there, right? So let's say I write my code, right, and then I try to call ASCII.equals, but since I used UTF-8 literal for the right-hand side, it doesn't compile, right? So now I change my call side from ASCII.equals to, left dot sequence equals right? So people already have to deal with the difference in behavior anyways, right? Because now you just force them to express it in code, right?
I mean, you're calling a different API, but it does presumably what you intended, which was a raw byte match over the left and right.
I mean, maybe. I think it's at that point, it's, yeah, I guess it really depends on what you think the expectation is, right? I would generally assume if somebody uses the ASCII type, they expect to deal with ASCII, right? Modulo, of course, the complications you brought up earlier, where it's like, well, I expect to search ASCII in something that may not contain that may contain non-ASCII characters, which I think is a complicated scenario to reason about, because you're effectively saying, well, there's some ASCII and some other things are non-ASCII, and where the boundaries are scenario specific.
I guess the thing that I'm really running, the thing that I find weird though, is if we had equals byte, for instance, and we would say our value add, as it were, is that we perform a check on both parameters rather than just calling sequence equal under the covers. Like my concern there is that returning false for literally the exact same inputs, like if you pass the exact same buffer reference in for A and B, returning false is a very, very strange return value. Like I would expect that most people would be better served by throwing in that case rather than returning false, because something just went like really weird at the call site. But now this is the only overload of equals it throws, because the other overloads return false.
I mean, that's a good point. I think sitting in an ivory tower right now, I don't know what makes more sense, but I mean, I think it wouldn't be unreasonable to throw, because you can literally say in the exception, look, if you just wanted a by comparison call sequence equal, right? But you asked for an ASCII comparison, and what you gave me is not ASCII, so I don't know what to tell you.
I mean, it would just be sequence equals, or if sequence equals, then you'd say if not ASCII throw, or if not ASCII return false.
Pretty much, yeah.
But like, because the only time that the missing overload would really come up is if you wrote ASCII.equals candidate, comma, and then a string literal, and then somebody in code review is like, hey, you should put U8 on that because why pay the widening cost? And then now it's like, well, now it doesn't match. It's like, well, yeah, now just switch to sequence equal, because like that's the only way that I can think of that someone would even kind of really notice it was missing.
I mean, we could have an analyzer that just rewrites the call site for you.
Have an analyzer that looks for the code that doesn't compile and tells you what the right answer was?
No, it checks for equals where you're passing a string literal on the right side. And then it says, oh, by the way, like your string literal is ASCII. Like I'm just going to rewrite this to call sequence equal whatever that same literal was, close quote U8.
Fair enough.
It would give you the exact same behavior.
Fair enough.
Yeah, I guess. I mean, I think it really depends on how you want to reason about the scenario, right? Like, I mean, and maybe I'm feeling this the wrong way, but if I'm processing ASCII, I would expect to find all the operations that I need on ASCII, and as soon as I have to look elsewhere, I would feel slightly dirty, because now I'm like, well, I'm no longer knowing whether I deal with ASCII or not, right?
I mean, we could, but all these other weird side effects that I mentioned kind of come up. Like, how does it work with the other overloads that share the same name? If some of them throw and some of them return false. Like here's the thing that concerns me, right? Say that you have a read-only span of byte which contains just the value 254, call that A, and another read-only span of byte, call this B, that contains the value 255. Encoding.ascii.getString of A and encoding.ascii.getString of B will return the exact same answer. Like they will return an answer that is true if you compare it for equality.
Right.
This API would return what? False?
Well, obviously,
Yeah, so
255 is
now-
not equal to 254.
Yeah, but encoding.ascii thinks they are.
Yeah, well, encoding.ascii really should have been throwing, but it wasn't.
So it's that's why, like, again, this is discussed in the issue, but that's that weird, heterogeneous behavior was why these APIs are now very quick to throw, with the exception of equals by char, if they see non-ASCII data, because we don't want to create something that returns an answer other than the answer that sequence equal would have given you, or encoding.ascii.getString would have given you, and so on.
Yeah, I mean, I think this is why it's complicated, right? Because naively, because I'm not an expert in these protocols, I try to call the APIs that deal with that. And if the API doesn't exist, and it's basically like, well, you need to decide what semantics you want, then I kind of have to understand the intricacies of the conversions and the behavior that you want. In which case, I just lose confidence in my own ability, I guess, which is why I find it weird if we basically decide not to make a decision and let it up for the user, rather than either returning false or throwing, in which case the user at least can't accidentally step out of ASCII without realizing it.
Yeah, and if we made this throw, like, that's fine, but now we have to figure out what to do with the byte char overload, which does not throw, it returns false, because it can get away with returning false if one of the inputs is non-ASCII.
Right.
Yeah, I mean, in the principle of we can always add things later, I think that the pared down, unless we want to address its reflexivity, which we'll talk about as soon as we get to equals ignore case, that the pared down version it solves a problem that is not currently solvable easily without the API, and it does it in an easy way and an efficient way. And then the byte one, if a lot of people complain, we can always add later.
Yeah, so this is, I guess, my question too, is like, why do we think for ignore case we would support strings on both sides, and here we only support bytes? I guess I don't understand why.
Ignore case can be very highly optimized if we know that the input is all ASCII, or if we know that the input considers only ASCII transforms.
But you do still have equal ignore case with byte. So you're going to have, like, here you're already having to answer the question of what happens if you call equal ignore case A, comma A, and it contains non-ASCII values.
Sure.
So if that's going to throw, then we can add equals byte, and that throws. And if this says false, then that could return false. Like, if you're adding the byte one here, which probably makes sense to have, then you're already deciding what it means.
That is a fair argument, yes.
I mean,
That
same
would be
can
really
be
sad
said
for the ignores case, though, right? Like, what if I've already validated the byte somehow?
If only we had data structures that corresponded to pre-validated types.
Yeah, this goes back to we don't have a data type for this stuff. Yeah.
It turns out that validation is actually really fast, because it kind of has to be done anyway as part of the comparison. So you're not really paying any extra cost.
Yeah.
The UTF-8 validation is considerably more expensive compared to this. When you constrain your inputs to just ASCII, like, you're maybe wasting 2-3 nanoseconds, if I had to guess. Like, it's not going to show up in any real perfect chart.
Entire nanoseconds? Excuse me?
Entire nanoseconds.
But what if my string's like 5 gigabytes? No, I'm just kidding.
That's like
Great.
6 cycles on the new upcoming CPUs.
Yeah. Then we rely on branch prediction to say that's not going to get called.
The diff is complete. And speaking of 5 gigabyte string, I think we have array length and span length limitations, so nothing more than 2 gigabytes of UTF-8.
Oh, thank
will
God.
fit.
So, but like,
yeah. So
but-
what does equals ignore case do when it gets non-ASCII data? Return false?
It's written in there somewhere.
I bet you it returns false.
I mean, on the same argument as equals, it should throw, right? Because if I give it two identical strings, it's going to return false just because it's not ASCII.
It does not throw.
Because the argument I can understand for saying that the haystack doesn't have to be well formed, but the needle does when we are talking, index of and all of its friends, is that probably your needle is a literal. The trouble with equals is we can't force you which side you wrote the literal on, so we don't know which thing was nonsense that you passed in. One of them is a candidate, and the other one is a thing you expected.
Yeah.
Yeah, if you scroll up ever so slightly, you'll see in the comment above the type definition, it says that failure occurs for equals only if both are non-ASCII.
So if both are non-ASCII, then you throw. If either one is non-ASCII, you return false. I guess that makes sense because you're saying it didn't match.
Yeah. Correct.
Yeah,
Right. So it's basically so for equals, it would be if sequence equals, if not ASCII, throw, return true.
So all this makes sense to me. It just doesn't make sense to me why equals and equals ignore case is any different given any of those arguments. Because you still don't know which one is the validated one, and you still don't they could.
It doesn't matter because they're peers. They're equal. So either as
equals
long as
are peers
one of them
too as well. But
yeah.
I'm saying it's the same.
Yeah, we could totally say that those behaviors are unified across equals and equals ignore case.
I mean,
equals ignore
case is really you convert both of them to the same case and you call equals, right? So logically, right? So in that sense, you can argue that it's weird that equals and equals ignore case have different behaviors.
Well, I guess one consideration is since this is ASCII and all characters are exactly 1 byte wide, if you must validate, then you can't do the shortcut of if left.length does not equal right.length. But if you say that you only have to, I guess that's generally a confusing behavior with these if you have to do any validation whatsoever.
Not necessarily. We can still do that, Chuck.
No, because if you're
the paragraph
saying
that's at the top of the screen says we can do that, Chuck.
Oh, okay. I don't care about the paragraph at the top of the screen.
Yeah.
I care about what makes sense to users. What I'm saying is, if we have to validate either input in any scenario, then we must always validate the input, because otherwise you end up not being able to do other shortcuts or other checks.
I disagree with that statement.
Consider the case where you said if both of them are non-ASCII, we throw.
Mm-hmm.
Okay, so both are non-ASCII. That means you must validate both of them end-to-end, and you can never do a case of if left.length does not equal right.length, return false. Because
I disagree with that.
Because if both of them are, because that means if both are equal length, it will throw. But if one of them has an extra character, then it won't throw. And that's a problematic behavior.
So think of it this way. If there's the possibility of ambiguity, it throws. If we think we're going to get into a place where we're trying to perform some work and we realize that we don't know how to answer the question that we're being asked to answer, that time that two buffers of different lengths will never, ever, ever be equal. End of story. It doesn't matter if one's ASCII and one's not. There's no way this could ever. Similarly, if you the way that text is written right now leaves open the idea of saying if your needle contains non-ASCII data, but say that your needle is the letter A followed by some junk, and your haystack begins, say that right begins with A followed by some junk, and left begins with B followed by some junk. So they both contain non-ASCII data. When you compare them for equality, the short circuiting at the very beginning said A does not equal B, and then it just returns false. There's no need to do the full O of N walk.
Right, but then you get in the case of they are identical bitwise, and it throws because both of them contain non-ASCII data. And that just ends up with a very confusing behavior where users, if they slice their inputs, if they do all kinds of stuff, can randomly suddenly start throwing versus getting false. And so I think we need to say it either is just another sequence equals effectively, or it always validates both inputs.
I don't think it's
already
really
the case always
today.
returns false for non-ASCII data. Did we talk about that? Like, even if they are sequence equals, like, is that bad?
It gets very weird because if you have say that you have some non-ASCII input on the left and the exact same non-ASCII input on the right, and it returns false or equals, and then you call, encoding.whatever.getString A, encoding.whatever.getString B, and it returns true for equals. Like, what on earth just happened?
I mean, that's the exact behavior that I'm already saying is confusing, because you can run into that because of it saying false, but neither of them are ASCII data. And it really depended on if you sliced or not with an extra character. There's just all kinds of edge cases you can run into. And so I think we either need to say we just always validate and treat them as false, or we just always validate and throw if either of them contains non-ASCII data, because basically effectively each one is the haystack and each one is the needle. And since each one's the needle, technically you need to validate both. And then it's consistent with all the other APIs throwing for the needle.
It's the way that this is thought of isn't that both are simultaneously the haystack and needle, it's that either could be the haystack or the needle. So it's an either or check, not an both and check.
I don't agree with that, because we typically treat equals as commutative, and therefore you can't have it differ in behavior based on whether you do left equals right or right equals left. And
Correct.
So therefore you should validate both.
Or validate, or allow allow one of the two to be invalid effectively, because we simply do the check on one of the two instead of both.
Right.
Like we say, A failed, let's try B.
Right. And so what I'm saying is we should either say we always validate, or we never validate except for saying that two in equals string, or other than saying that any ASCII, non-ASCII data makes it return false.
I think so. Any non-ASCII data returning false for reasons I've already said is a non-starter. Like it would be too wildly different than the existing .NET APIs, where it actually opens up a giant pit of failure for people.
Okay, then I think
like,
we
what's
need
the
to go with
non-starter?
validate.
I think this proposal's a non-starter. Wait, why is it a non-starter?
So sorry. So here's the issue today, right? You have a string that contains non-ASCII data, A, and a string that contains non-ASCII data, B, and you call encoding.ascii.getString on A, encoding.ascii.getString on B. You compare those two return strings for equality, it's going to return true.
Yeah, but that's already the case where you can do encoding.ascii.getText A and B, and then do string index of, and it's going to return a different result than this API will, because one of them will normalize the results to invalid characters or whatever, and the other one will throw. And so you're already getting different behavior between the two of them.
I don't agree that that's a non-starter. Like I call getting encoding and encode it, and it's different. What's bizarre to me is what Tanner's harping on, that like if I change like the left or right to be one more or less character, it like stops throwing and starts returning false. It's gonna lead to like some exceptions that only come up like randomly in production. Like, and you can do the fast case not equals if you just always return false for invalid ASCII, and like you're gonna have to validate ASCII for equals anyway. Like, and it's easy enough to explain. It just always returns false if either left or right has invalid ASCII. Like, it's very simple.
Even if you pass the exact same buffer on both sides.
Yeah, It's very simple to explain. I mean, there's sequence equals if you want that to be equal.
It's not ASCII, so it cannot be considered equal by ASCII rules.
I would say if you really are set on doing validation, at least throw instead of return false. Remove the ambiguity there.
So that one, I think I can live with that. I think to me the thing with the haystack and needle thing is easy to understand which argument is basically validated and which one is just compared to, right? But this one is, because it is either left or right, you end up in this bizarro world where depending on how long the string is you're passing in, you get different behaviors. So
Right.
I think in that case, if we just say we always throw, I think that's also fine. But I think it would be weird to explain to people like, oh yeah, you were throwing when the string was shorter, but now that the string is longer, you just return false. It's like that. I don't.
Again, that only occurs if both inputs are non-ASCII, and the overwhelming use case that we imagine for this is that at least one of the inputs is a literal.
But
Right,
if that's
but
true,
that-
why do we care then to optimize this and not throwing?
Well, what I'm saying is we would, at this point, we would be punishing people effectively for saying like, oh, you've passed in a string literal. Like, we know that we can make a short circuiting operation here, that now just because people might be misusing this API, we now can't do a simple O of one check, and now we have to do a full O of n walk on the input.
Not
And this is why I like
necessarily-
returning false. You should return false.
So, Levi, not necessarily. UTF-8 literals are embedded as RV static
Yes.
metadata and .ro data. We have all of the necessary stuff already to be able to constant fold away simple lookups and other checks. We could just have the validate is ASCII API, have a short circuit where if the input is read-only data, then we just check if all the data is ASCII in the JIT and constant fold.
compiles
That
them,
is
yeah.
possible.
Even
But-
for an
but-
API like this, which would be like going through 2 or 3 different call sites to do it.
I mean, we would end up writing the API such that it's validate, call internal helper, much like we do with half of our parse and other APIs.
Okay.
In which case we can aggressively inline the validation. And so worst case, you get 3 calls in your call site, but that's still short code. But I think in general, my point was, I don't like the behavior of differing based on input lengths. I think that's going to be a pit of failure. And so I really want it to either be we always return false or we always validate and throw.
Okay. As long as we can make the literal scenario, which I think is going to be the overwhelming use case, like be effectively free, such that we can short circuit as appropriate, then I'll let that slide.
So is your only pushback on returning false if both strings happen to be, if both basically buffers happen to be bitwise identical, that's odd?
That is very odd to me, yes.
But is that the
Well-
only reason why you don't like it, or is there another one?
The other reason I don't like it is that it gives a different answer than encoding.ascii.getString.equals.
But encoding.ascii.getString is just 100% wrong. The replacement
Not
character
necessarily.
value should not have been the default. It is a stupid thing. It fucks people over. Like, it is the wrong behavior to have been the default, and that's the only reason there's a question here. If it
So
threw
what
on
you're
nonsense
saying,
input,
then-
if it threw on nonsense input, then we wouldn't be having this discussion. We would say we can just return false arbitrarily because the existing patterns would have already thrown.
So why would we not throw a nonsense input then? If you want them to throw a nonsense input.
It was dealing with high level concepts and trying to make things easy for people, and presumably the purpose for adding this is to make things fast, which is why you put it in system buffers.
Yeah, we're also
Exceptions
not
are
producing
faster
a
than returning
string,
false.
right? We're not producing a string. We're saying whether or not something's equal. And I get that, like, yes, in this like narrow case, it's arguably wrong, but like it's not sequence equal, right? And this is the difference. Like if you give it non-ASCII input, it always returns false. That's the difference from like sequence equal.
I mean, what you're really
Right,
saying is,
and-
are you equal, under the rules of ASCII, right? And it's basically like, they're like the ASCII rules don't apply because your inputs aren't ASCII, right? You're kind of in the, in the mathematical sense, you can imply anything from false, right? So in that sense, I think returning false is, in my opinion, not an insane answer. I think the problem with the argument that encoding.ASCII gives different answers, isn't that true for large chunks of this type anyway? So if they all return the same thing for all inputs, then why do we add the new APIs to begin with? Why can't we add overloads on the existing encoding types to make this stuff faster? I thought the idea is that we do return different answers.
So keep in mind the encoding type is just about transcribing data from one format to another. The encoding type is all about like taking one bit representation and turning it into a different bit representation. What these APIs are considering, aside from equals, is like doing checks beyond just simply changing around bit representations. Like uppercase conversion, for instance, is it is not just bit twiddling. Like there's an actual, there's an actual linguistic map that has to be queried.
Right, but I think the question is, so you're saying that we can't do equals because encoding ASCII get string left equals encoding ASCII get string right will return a different result. But the same thing is true for index of text value versus index versus string, or encoding ASCII get text dot index of encoding ASCII get text. They can equally return different results because we've clearly stated that the value is validated here, but encoding ASCII get text will convert it to a normalized default value if it's an invalid input. So every single one of these APIs will differ from the equivalent encoding ASCII get text.
Well, the problem is there really is an equivalent API, right? I mean, in both cases, you're effectively doing the operation on the string with the string methods, whether it's equals or index of, right? You just happen to start off with, I have some bytes and I call, encoding.getString.
Right, and so every single one of these APIs fundamentally differs and is not equivalent to encoding ASCII get text. And so I don't think that's a starting argument for any of these because it's always going to be different.
Yes, so I think I'm leaning towards that as well. I think you can probably make a compelling argument that equals is just special in .NET because when things are not equal, like usually like other things can be weird. So I'm sympathetic to the argument that it's weird to return false when the input is basically bitwise identical. But I feel like the alternative is worse because I can no longer explain what it does.
And that's already the case for some things for other APIs where equals may not return true just because something is bitwise identical if there's other considerations at play in the representation.
Mm-hmm.
Okay, so let's back up and consider Kestrel scenarios then, right? Kestrel wants to be able to put keys inside of the dictionary, presumably keys that contain ASCII text, correct?
Mm-hmm.
So if Kestrel is trying to say under an ASCII comparer, are these two keys equal and the keys happen not to contain ASCII text, what happens when Kestrel tries to insert the exact same value into a dictionary? Because remember, equals didn't fail, equals returned false, which means from a false return statement, this is a brand new unique key that the dictionary has never seen before.
Right, which is the argument for it should always validate and throw.
Not return false, but throw.
Otherwise, you have the exact same issue of they compared two strings. One of them was just a little bit longer, and so they decided to go and put the other value into the buffer, even though it contained non-ASCII data. So either Kestrel needs to know that it's valid, and we must always validate and throw, or it doesn't matter. They should be validating independently, and we can just return false.
Well,
sure. So for dictionaries, at least Git hashcode would throw if things are bad.
I mean, I think the argument really is that a comparer probably needs to throw because of the dictionary scenario. But I think a static class like this, I think we can still decide that equals wouldn't throw. I think at that point it just becomes like who is supposed to call. What is it?
I mean, the real trouble is
ASCII,
non-ASCII right? Data here is nan.
Yeah, pretty much.
Right. Equals needs to return false, but so does not equals, and we don't have a not equals.
Yeah, that's I guess a fair argument.
So everything that Tanner hates about nan is what's going on in here.
That's why we should defer to Tanner because he's the nan expert here.
And I don't care if we always return false or throw, but I think it has to be one of those two. I don't think we can have a case where it sometimes throws for invalid input and other times doesn't.
Okay, so if we return false, then at the very least, get hashcode should return an actual exception if it's sees non-ASCII data.
I can get behind that. I like
Yeah.
returning false as someone who's worked a lot on Kestrel. We'll validate our inputs.
Yeah, I think that's fine too. If we return false, that gives us the shortcut and allows us to do very fast comparisons. And then for the dictionary where you always have to get a hash code, that will do the validation.
Yes, because that way, yeah, as long as we don't have get hash code returning 0 and equals returning false, like that's just a dictionary flood attack waiting to happen right there.
Right.
I mean, because presumably try get hash code returns false if the value is non-ASCII.
Correct, because
So
we
get
don't
hash
know,
code would
we
be
don't know what to
throwing
do.
because try get hash code returned false.
Yeah.
So we've already defined that behavior.
So I think that would be an acceptable. I just don't want to end up in the scenario where we sometimes do X and sometimes do Y, and then users have no way to rationalize really based on arbitrary inputs that they may want to slice to similar lengths or just compare arbitrarily, etc.
Clearly, we need a try equals with a bool out parameter.
I mean, that was suggested in the issue.
Was it really? Okay.
Well, not necessarily that shape, but the same idea where you could see if it returned false because there was a mismatch.
I think that's almost compare to, where you say 0 is equal, -1 means that left is invalid and +1 means right was invalid, which is basically how NaN works with compare to.
How the heck is that sensible?
Ask whoever implemented the compare to for NaN 23 years ago.
I guess for that, I mean, it's kind of more like the question of like, if you sort a bunch of numbers, which one do you want to see first? Or do you want to see the NaNs first? Or do you want to see the numbers first?
Yeah, hence our API review of last week of what we do in .NET doesn't necessarily make sense, and IEEE has a well-defined rule here called total order, and we're exposing a new type to support that.
See, as a German, I can just say, do you want total order? Not good, not good.
So what does this mean for the needle and haystack APIs? So they wouldn't throw, they would just return false if the needle's nonsensical?
No, I think for that it's fine, because the same parameter receives the same validation all the time, right? It's not a function of length or something else.
Well,
it's just like
not
You're
necessarily.
always the things that are currently called text and value, and let's just assert they get renamed to source and value. Value gets validated, source gets matched.
Yes.
Basically, the validation means if we throw, it means we need to always throw, which means we always need to validate the needle. We can't do something like if value.length is greater than text.length, return -1 because it could never match. We'd still have to validate value and throw.
Right, and I think you were saying that we could optimize, we could make some tweaks within the method in order to get some JIT optimizations for the common case where the needle is in fact a literal.
Right. If we want to, yeah, and we could optimize away the validation in that case.
Right.
Okay.
Theoretically, Igor Bogotov's probably who we want to talk to confirm that, but I believe it should be feasible.
So then, but in those cases, a needle failure would be an exception rather than a false return value or -1 or whatever.
Right.
Right.
Okay.
I'm not against us returning -1 and just saying if anything's invalid, then there is no index of, and only having something like get hash code actually do the throwing. I'm not against that, but I think we need to either say we return -1 or we always pre-validate and we don't before we do any other shortcuts.
For the index of inference.
Yes.
Yep. Personally, I would prefer to return -1 because validation takes some time, and these APIs are supposed to be high performance.
Well,
and
I
also in the places where I was using them when I was implementing it, most of the inputs were validated, pre-validated, and I really didn't need exceptions and an extra validation.
The validation has to occur as part of these APIs no matter what. because when we're doing the loop comparing, even in the best case of SIMD optimization, we still, for every 16-byte sequence we pull out of value, we have to check if any of them are invalid before doing the comparison against text. That way we know if we should return -1. And so there's no real performance optimization outside the only difference is if you're doing the validation upfront and therefore skipping the checks in the loop because you know it's all valid, or if you're integrating that validation into the loop, in which case you can just do a test Z and the branch predictor will say 99% of the time this is false, so make it a cold path.
I mean, for literals, we can optimize. Adam, the places where you found that these APIs could be called, was the needle a literal?
Oh, not always, definitely.
But I assume it was in the majority case that you're asking index of some well-known value.
Let me take a quick look.
As opposed to just index of some arbitrary variable.
And if the value is frequently something like, less than 64 bytes, then we're not going to have a huge consideration of invalidating the cache by doing a pre-validation loop, which is the biggest concern generally of doing it before.
I mean, the thing is, ignore case needs to look at all of the needle anyway. So, like, again, validation there isn't significantly anymore.
Well, potentially all of the needle, right? There's only
assuming that there's a match, yeah.
Yeah, there's only 26 possible characters that need to be adjusted, and it's pretty easy to SIMD optimize that to only uppercase the characters you need, and so it's only
like
if it's only if it's a match does it need to consider all of it. Anytime it's a no match, it can just quickly return none or -1.
Yeah, we've gotten very good at SIMD case conversion over the past few years. It's funny that we don't actually do SIMD case conversion outside of like our outside of prototypes. But we've gotten good at it.
So I think we discussed this to death now in terms of the position. So I think where we landed was to say equals we are okay with throwing.
Returning false, I believe, was the consensus.
Was it? Okay.
Yeah, I think we initially said throwing, and then enough people said that returning false was okay and would make sense, provided that get hash code will always throw for invalid input.
Okay.
Yeah, I like the analogy of invalid inputs effectively being nan.
Yeah. So that means that equals byte is essentially sequence equal and is ASCII. So sequence equal left right and is ASCII left. We don't need to ask if right's ASCII because we already know that they were equal.
Yeah, we can do some sleight of hand under the covers to optimize.
Sure, but logically that's the
correct
the implementation. So equals, you proposed only, you were opinionated in types on the left and types on the right, but equals ignore case you were flexible.
As in like why does one have byte and one have byte char? Is that what you're asking?
Well, I feel like what you left, because you left out byte because of all the reasons we were debating, but you left byte char, but then equals ignore case has byte char and char byte. So I feel like they should both have both or both have only one.
There's no char.
We either have an opinionated
byte,
order or we don't.
There's byte char and byte char, but there's no char byte.
Yeah, if you want that reflexive one, then
I thought that it was already reflexive. So
sadly it's not. Like that's another thing that I find confusing, that you can't swap left and right in all cases.
yeah, if it's needed, then go for it.
Yeah, I mean, I'm fine with saying we have an opinion. I just got it wrong on which opinion we had. Yeah, so why did you remove char from non-ignore case equals?
For the exact same reasons we've been debating, because it adds an ambiguity as to like what happens if you pass the exact same input and it happens to contain non-ASCII characters. Like, do we return true, throw, false, whatever? But it sounds like we have an answer to that now. So
right. The fact that we had equals ignore case byte means we had to solve the problem, and now that we've solved what the truth table looks like, we can make both of them have all three or all four if we care.
Yeah, like there was actually an answer written at the top for what this API was designed to do. But like, yeah, throw that out and use a truth table we just made. Perfect.
And why doesn't index of have byte?
I think the reason for that was that the expected use case is that you're passing the literal there again, and there was no real need for us to do any value add over what the regular index of extension method did.
But if it's going to validate ASCII input,
I guess the real answer is no one was asking for it.
It almost seems like we should be having the same overloads for all of these methods, because I expect everything that equals applies to will also apply to index of. And so,
true, but part of this too was trying to figure out like the minimum viable product that people could actually use within the code. And I've not seen no one at all, like clamoring for an ASCII index of method. Like you have a byte sequence that the needle byte sequence that's almost certainly a literal, like just call index of. Like, what value are we really adding over the existing memory extensions method in that case?
Consistency and guarantees of what it does.
Sure, and if we now have a much stronger statement about how and when we validate and all that good stuff, then maybe there's value add that we can add there. I still don't expect we'll call it internally.
And I think that's fine, but to me, there's a huge argument for discoverability, because if we tell people you want to deal with ASCII, come here, and then all of a sudden they're like, well, I have I've got actual ASCII input and I want to search within it with this ASCII string literal. And now you're telling me I need to use read-only span.indexof instead of ASCII.indexof. That just leads to, I think, confusion to end users. And we can, if we want to simplify this internally as just, text.indexof, then and is valid value. That's fine, but I think for discoverability and consistency, we want to have all the same overloads for all of these methods.
So
even though they're going to be more expensive than the other thing?
Well, they don't have to be more expensive than the other thing, but yes, I think there's guarantees and other things here which are important.
I guess I don't understand how I thought the previous discussion was they're necessarily doing more work to validate the ASCII-ness.
Right, but if the input is always a literal, then we should be able to optimize that literal validation in the JIT.
And then it would just become sequence equal at that point.
Sure, but the input is not always.
Right, in which case, using the span index of would be an incorrect equivalent.
No,
because it's not doing the same.
It's not an incorrect. It's an incorrect equivalent in our implementation of an ASCII such method, but it's not an incorrect equivalent for the 99.999% use case for these methods.
Right, then it becomes a potential pit of failure and bug in that if the user happens to pass in non-ASCII data, it will return it will not throw and not return -1 for something where this API would have.
Exactly.
Which is a potential bug.
No. I mean, sure, if someone actually wanted that validation performed, but you very, very rarely want that validation performed for those index of operations. You generally do not care in those cases. You you know kind of inherently that the data you're searching for, even if it's not a literal, is already ASCII. And if it's not, you usually don't care anyway. You just want to know, does this thing occur? So we'd be pushing people, by your logic, we'd be pushing people towards the API that is doing validation they don't need and is more expensive as a result, and we can't optimize it for them.
Well, I wouldn't say they don't need it. Like my argument for not including it originally wasn't that it didn't have merit. It's just I didn't think that people either internally or customers would actually want to call it.
But that's what I mean.
Yeah.
They won't want to call it. Why won't they want to call it? Because they don't need that functionality.
Right. That's kind of what I was getting at. Yeah.
And they all they need is memory extensions.index of. Just use memory extensions.index of. Like what?
I don't think we want to push users towards not sanitizing their inputs. In fact, I think we want to tell people, use this API, and the few people who actually care about the perf to the level that we do will know that they can go use index of instead because they don't need to validate.
I want to quote you in the future as saying we don't want to push people toward not sanitizing, not validating their inputs.
For
Yes.
public API surface exposed at this level and not under interop services, yes.
Yeah. Okay. So that said, yeah, like I could see why I could see why, you know, somebody, maybe a small handful of customers would maybe want this behavior where it's like, well, I really do want, you know, I did expect this to be ASCII. But the overwhelming majority of customers, I think, are just happy doing a straight up binary equivalence check, which is what memory extensions already gives you. So I guess I wouldn't be terribly sad if people stayed on the existing API and didn't move over to this one.
In general,
I wouldn't be surprised.
I don't love the idea of duplicating every single API just because we can, when effectively all it's doing is a check the user can do themselves if they want to do that check.
And it's something we can add later if we need to. Like
Right,
if there is a demand for it, which I'm personally, I don't believe that, but if there is, we could add it.
We can also have the API be much more efficient than what the user can do themselves because we can SIMDify it and integrate the validation as part of the comparison loop, which logically you want to do anyways if we were planning on throwing, or
Yes.
if we were planning on returning -1.
Yeah, like doing the validation as part of the check, as we mentioned earlier, is actually pretty cheap.
Yeah, I'm feeling minimalist, and I agree that all that we would be doing with index of byte and index of char is we're adding the if not is ASCII throw for you. If people really say, I find myself writing this helper, why didn't you do it? Then we can add it. But I expect that, this will all be desert before that happens.
Okay, then why are we exposing byte for equals ignore case?
Because it's a
Because
transformation you have to do.
Yeah, it's difficult to do yourself, basically. We are actually adding value.
And then for equals, equals and equals ignore case look different now, and that's just weird.
It feels really inconsistent to have overloads on ignore case that aren't on the ones that take case into consideration. Because we're telling people use this API for this, but use this other API for this, and that's going to make it much harder to discover, to rationalize, and to understand the code that you're working with. Because on one hand, you're going to literally see the words ASCII.indexOf, and in the other case, you're just going to see span.indexOf. And even if one is faster and happens to not do validation they technically might not have required, it makes the code harder to understand, reason about, rationalize, maintain, etc. Because the intent is no longer there.
Well, so how about
I
this?
think that's true, but I think that's true regardless of whether that additional API you're talking about is added or not. Memory extensions.index.of exists. Lots of code uses it. adding yet another index of doesn't take away the fact that code now needs to decide which to use.
So
right,
if,
and when they're dealing with ASCII text, there's a clear, you should likely use the ASCII index of API because it will explicitly take into account ASCII information.
Unless you don't want exceptions, in which case you need to use that. Unless you want this, in which case you need to use that. The more things we add, the larger the decision matrix.
So if our real value add is in the ignore case APIs, because otherwise you would have to like convert read-only span of char, go through globalization, all that good stuff. If we think that that's really where we could add value, what if we ignore everything that's just not ignore case right now and focus only on those? Would that kind of, would that help in the sense that it would narrow the scope to what people might immediately find useful?
Well, yeah, okay, I guess the point that I made of equals ignore case looking different, we would hit once we talk about index of ignore case versus index of. But because the same size non-ignore case is, you know, basically vanity and squaring off the corners here. The part where it's doing you're looking for, you have a system.string literal that you want to ask, this payload should be ASCII, is there a match? Like, can you find this in there? Like, it's doing value, whether so ignore case is value, widening and narrowing is value. The one that's just an exception in front of asking the go find these bytes is less value.
I'm not actually sure the widening and narrowing case is adding value. And the reason is that if what Levi's stated a few times is true, and most of the time the value is a string literal, then the user is better off passing in the same sized literal as the input was, because that makes it easier for us to SIMDify the code, and we don't have to repeatedly extract and then upcast or downcast for each iteration. Likewise, when it's non-ASCII, when it's a non-literal, we are likewise, except for very large values, that is a value input has a very long length, we are likely better pre-upcasting or pre-downcasting so that we can have a tighter inner loop anyways. So I'm not convinced that the byte char mixed versions are actually adding a lot of value over users just doing the first upcast and or downcast and pass in the same size on both ends.
Yeah, so doing an upcast or a downcast ahead of time is very useful for UTF-8 because UTF-8's variable width. In the experiments that we've run, doing it on the fly, just for ASCII and other fixed width encodings, actually surprisingly works pretty well. I was shocked to see that too.
I mean, to me, the cases that are, they're not solid, they're just, speculating, is where you're mixing things with, you have ASCII data from a file or a network, and you're doing things that involve, dictionary of string to something, and you're doing tests where you already have the key as a string, and maybe it's well known, but not necessarily a literal. And that's where you want to ask now, like, does this start with the thing that we're going to care about? No, then move on. We don't need to convert the whole thing. We only care about the first in code units. And let's just see if we can skip a lot of work.
Yeah, and one of the scenarios that I think will come up quite a bit is, say that we're just reading some bytes off the network, like the incoming URL from a web request header. And I found where the slashes in this thing are, and I want to extract this part of the path segment. And I want to know if, this particular part of the path, matches some username that's coming from a database somewhere. Like I know for a fact that my business logic already has everything in ASCII. This username is not a literal, but it is a system string because I got it from my database layer, and I just want to do a match as quickly as possible. Like a read-only span of byte and read-only span of char overload would help there.
Right, but not that much more than just a API that converts between the two. And if you know it's all ASCII, then you know definitively the size of the byte buffer you need, which does it up front and instead of part of the loop. And that's going to end up making the inner loop faster and tighter. And even though it's going to be only a couple nanoseconds, it's still likely better overall than doing that particular part as part of the loop, because on larger inputs, doing it as part of the loop will degrade performance.
From a raw performance perspective, I could see that, but it's more code that the developer has to write, which means more opportunities for them to get it wrong.
All right. Anything else we need to talk about? Any other concerns about the APIs, the shapes?
I mean, it sort of sounds like Tanner saying close.
I'm I'm concerned about the overall inconsistency between the byte and char overloads. And so I think the most correct thing to do is to provide the same 4 sets of overloads for all of them, or to only provide byte and char overloads. And for users to, especially if the most common case is literal inputs, to just use the right literal, and otherwise to pre-convert, and to add the mixed overloads later if users ask for it.
Well,
But I don't think I don't think
your concern though about the ambiguity about like what the return value is and all that good stuff.
No, it's
Right.
not about the ambiguity. It's the issue I have is when it's, so we've got some APIs that expose byte char byte, and char.
Mhm.
And some that only expose byte char and char byte. And I would expect us to be exposing byte and char as the basis for everything, and having the byte char and char byte overloads only where users have indicated it adds enough additional value. But we've got it in that we expose all 4 or byte char byte, which is basically the opposite of what I'd expect, in which I think it just makes an overall more confusing state for the APIs we're giving to users. And I personally don't like telling users just go use index of when it doesn't do the same thing. Even if it's if you don't need validation, it's okay to use here, because there's that if.
So is that for the index of overloads then, the index of method group, or just kind of everything all around? Because there are APIs like, case conversion, which having all 4 would make sense.
Right. It's I think we should either have all 4 everywhere, or we should have a different set of 2 as the default. And rather than having the mixed as the default for the other cases, we should be having the byte and char.
Well, I guess, what do you mean by default in this case?
So we've got X and X ignore case. All of the ignore case ones, you're providing all 4 overloads for each.
Mhm.
And for things like Git hash code and other ones that only take 1 input, you're providing both byte and char for each.
Right.
But for just X, you're providing only mixed versions, meaning one input is byte and one input is char.
Okay, so so you're looking for some kind of uniformity, consistency across that.
Right.
That's a fair statement.
I would expect either we expose the same set of overloads on all of them, or if exposing all of them is a concern, I would expect the normal default to be the non-mixed cases. So take T, where T is byte or char for both inputs.
Mhm. Okay.
Because in my main reasoning for that is I think that's more consistent, and you can use those APIs to do everything else. Whereas if you only provide the mixed ones, you have to tell users, go use this other API that's on a different type, on a different namespace, and which doesn't do the same thing.
Yeah,
So
the
ASP
only problem is that there's setup that you have to do before calling the homogeneous APIs.
Right, but that is a helper they could build themselves.
Sure.
So ASP.NET has this string utilities class they include into a bazillion different assemblies, and its whole purpose in life is to do equality across chars and bytes. We have a similar thing in Sockets HTTP handler. Your argument is no one should be using those, and we should instead do a conversion first and then use the built-in ones?
No, I'm saying those helpers are fine. I'm saying that only providing those helpers without also providing the baseline functionality of both inputs are the same type is what's confusing. Because that's not the default for most APIs across .NET. We don't expose APIs that take in an int and a long. We expose APIs that take in the same T on both sides and users upcast and then build their own helpers, or in the few cases where we found T in and U out is beneficial, we've provided that as well.
My concern is we already have those APIs. We're trying to add the additional APIs.
We don't have those APIs. We have a different API that might be usable if you don't need validation.
No, we have the APIs, and you can validate if you want to.
Well, kind of. The way that, so if we had just byte or char, for instance, and then people wanted to go from byte to char or char to byte, the way that they would do that today is through the encoding.ascii class, which will munge the data while doing the transformation. We would not be munging the data. We would be giving you an actual answer saying something went wrong while doing this. So it would actually be a different answer / coding paradigm.
Well, wouldn't they just use ASCII to?
Sorry, Levi, I just want to clarify. You're talking about ones that take char and char, or ones that take char and byte?
If you needed to create some uniform representation, to say that the only overloads that we gave you were byte or char, but you had mixed input, you would need to unify the inputs yourself somehow.
Right. No.
And that unification process will munge the data.
That's exactly my point. For cases where you already have byte or you already have char, we already have APIs that let you do that. What we're missing there is an API that lets you validate, right? We don't have the everything is ASCII API. And if we had that, then you can, if you do want that validation, you can do that first, and then you can call the other APIs, and maybe we could do it more efficiently if they were combined, but it's functionally possible. We lack the APIs today that allow you to do the mixed ones, and it's a very complicated experience to figure out how to do that and how to do it efficiently.
Why is that complicated when you know all the data is ASCII? Like with this class being exposed, so we don't munge the data, it's ASCII.2UTF-16, where you've stack allocated in a buffer or allocate an array that is exactly source.length.
Yeah, but the people that want to do this don't want to allocate, so then they're avoiding the allocation. So then they're stack allocating, but then they're having to validate that the length isn't too long, in which case they're pooling, in which case they have to return to the pool. And now your thing that was a one-liner is now very complicated.
Is a small helper that you've added that everyone has to write everywhere.
Now, and which we've rejected. A helper if you're talking about having to both stack allocate and rent and return and not have a delegate invocation.
Yeah, I mean the validating converter is new ASCII encoding of false. Like we have the validating converter. It's just not as easy as calling encoding.ascii.
With an asterisk, but yeah. Like it will throw if you don't want it to throw, if you just want it to return, something went wrong, like an operation status, for instance, while you're hooked. But yeah.
That's what try catch is for.
Fair enough. Okay, so I think like to address Tanner's concern, like I think it would probably make sense just to unify to say like if for whatever method group we approve, we would want all of the overloads possible. Would that address your concern, Tanner?
Yeah, it would be more APIs, but it's no more APIs than we've added in other places, and I think they are very convenient for users and help with discoverability, help with ensuring that users have the tools they need available to them up front, and at the same time, the other APIs they need are exposed.
Yeah, because I agree strongly with what Steve Tobe was saying as well, which is, you know, if we tell people all we have is byte or char and it's up to you to do the conversion, like it might only be a few lines of code, but as I mentioned earlier, every few lines of code that we force people to write is a possibility for them to introduce bugs when we could just do it ourselves for you.
And if that's more, if allocating a buffer is more complicated than we want most users to take on, I'd argue that that's something that we should be looking at addressing more generally rather than exposing mixed APIs here, because
I agree.
more users will hit that and will not be able to move themselves forward.
Yeah, I do agree with that statement. I think we can actually get away without any type of rental here, but we'll see.
I'm not going to fight against it, but I still believe that exposing a bunch of APIs here that are just validation on top of functionally validation on top of other APIs we already have, and validation that throws is going to result in unnecessary choice that ends up causing, there was concern earlier about causing bugs by not having them. I think we will be potentially causing bugs by having them.
Having bugs by validating that the input is ASCII?
Yes.
Yeah, I mean, it's kind of more insidious in that, like, you don't notice that it's like a bug, but like, I don't know, maybe it's fine because it's so cheap, but I kind of agree.
I mean if you're calling an API that says ASCII and you're giving it UTF-8 data, like, oh man.
Like, I would actually think the opposite, in that not validating is more likely to cause silent CVEs, security issues, and other problems because they've got inputs that that they think are valid that aren't.
And I think we're going to find people calling them. It doesn't matter whether it's ASCII or not. For their scenarios, it doesn't matter, but they end up calling ASCII.indexOf because it's this concise, newfangled, nice-looking thing. And they randomly get exceptions and failures because their validation is being performed that it wasn't actually required.
Right,
It cuts both ways.
And that's when they go and say, oh, I don't actually want ASCII because I don't have ASCII data.
Maybe after their production incident.
Right,
Well,
but that's something they should be.
Yeah. I don't see this as any
testing
different
in the first place.
Yeah, this is no different than, you know, people calling int.parse within their business logic, but oh, it turns out, you know, I actually have more than 2 billion records in my database.
Yeah, absolutely. But the point is we're exposing a bazillion new methods, and that introduces a lot of choice, and choice in and of itself is a problem.
Well, these APIs are opinionated. These APIs are strongly opinionated because they want to force, they want to steer people down like a direction that they're less likely to encounter issues or less likely to encounter bad data, processing bad data.
And I don't think that providing more choice is an issue when the choice is in terms of overloads. If the choice was in different behavior, that's the issue. And that's being introduced no matter what here, because they have the choice of, do I want validation or not? And so the choice is always going to remain the same of, do I want validation on my inputs or do I not? And if I do not, then I am free to use indexOf.
I still continue to disagree. There are other APIs that take, if APIs take, you know, arguments that match your types, and so you can call them, that is different than APIs that don't take your types, so you can't call them. So adding overloads, one of which duplicates a set of types being accepted that already exists elsewhere, that is introducing more types.
Okay,
more choice.
So then where's the API overloads that take in byte char and don't validate if that's going to be an issue
No,
for the API.
the byte char ones are the valuable ones. That's what I'm arguing for. Those are the ones that add value here.
But they validate, and you were just arguing for they may not want validation.
No, there's conversion happening, and therefore validation is effectively required. There is something there's a conversion that's happening, and so inherent to that is some sort of validation. In the ones that aren't that are the same type, char or byte, and there is no conversion, then we're layering on opinionated validation that, according to the types, isn't actually required.
So for any of the ignore case APIs also perform conversion, even if it's byte, char. And in fact, I argued in the issue that even not index of APIs, not ignore case APIs, just regular index of, are also performing conversion. The conversion just happens to be an identity translation. Like index of and index of ignore case literally are the exact same API under the covers. It's translate this element like from its domain to its range and then perform an equality check. It's just the translation either happens to be identity or case conversion. And because that is a translation nonetheless, we are free to define the workable domain and range for it. And the workable domain and range that I've defined across these is 0 to 127.
Yeah, and we honestly do the same APIs for UTF-8 and other things if we ever expose system text or system buffers text UTF-8 in the future, because at that point we have to do validation that the input is valid UTF-8.
Yeah, like at that point we can't work around it because we literally have to know what to do whenever we see something bad. We can't just treat it as opaque at that point. And this at least gets us, analogous behavior to that. There is some symmetry.
So where are we then right now?
So it sounds like everyone's good with the byte char byte stuff. Like, are we at least agreed that that's useful for people? It sounds like both Steve and Tanner were saying that that's goodness.
Yeah, I think it's fine for those to be exposed. I think Stephen and I just disagree on the value of exposing the byte and the char overloads.
Or the non-ignore case ones.
Right.
Like I don't see the value in equals read only span byte, read only span byte.
Right. So I see
I
from
agree with Steven, and when I was implementing these APIs, I was asking this question to myself very often. And please keep in mind that we are still exposing a method that allows for validation, so people can very easily build anything on top of it.
Yeah,
It
one
wouldn't be
thing
as
from
performant
Adam's
as we could
diff
do
that maybe we want to talk about before ending the review or ending the meeting having done nothing. You changed void to lower in place to bool try to upper in place, outing a number of things processed. Our general rule for tries is if you return false, you always out default. So what is this method doing? If it's supposed to do partial work, it should just be operation status.
There is an operation status API. This is intended to be a more, I guess, a simpler concept. Because for operation status, there are 4 possible return values. This has 2. It's either succeeded or it didn't.
Right. I mean, it's just.
Yeah, because we know that the buffer is not too small.
Sure, but if you're saying that you are going to allow false because you encountered non-ASCII data and then out the number of things that you successfully processed, that's violating our general rules for the try pattern. So you should be operation status even though you can only return 2 codes.
Will callers feel the need to have every single possible return value inside of a switch statement, and will it complicate the calling code?
I mean, if they want to write a wrong try, they can write it themselves, but I don't think we should write a wrong try. So that's the thing to noodle on during the next iteration is.
All right, Jeremy, can you repeat your feedback one more time? I didn't understand the objection to bool try here.
I think what they want is to allow it to return false and say it processed 17 things before it failed. And I don't think we've ever done that in a try. If a try returns false, the out is always default of T.
Got it.
Yeah.
And once you don't want that, then you can get rid of the out because the only out value will ever be valued at length. So I mean, if you're saying it only outs it when it's true, like, okay, it's a try method. But I assume the purpose of this was to indicate partial success. And if that's the case, it's operation status. That's our only partial success pattern.
Azure SDK would be a very heavy caller of this API because they do a whole lot of in-place conversions. We could expose it only as operation status, but operation status is just a more complex pattern. But yeah, we could.
So I mean, but anyway, so that's the thing to think about is what shape. Like we can be weird and say it returns an int of how many it processed, and it's up to you to verify that it was actually valued at length. But a try that returns false and out say non-default of T is novel in a bad way. So that's.
So why do we have a try one at all? Why don't we just have two lower in place, taking a span and just throwing when it can't? Like we really expect that a lot of code needs to handle that exception.
Because you might be doing some type of protocol processing where you're going up until the point where the data is no longer acceptable to you.
I see.
So the idea is that you find the end of the text at the same time that you finish conversion. Otherwise, you have to do like an index of beforehand, and now you're doing two passes over the data.
Yeah, so that the shape of what you want that to look like, the current shape is not right.
Okay, that's totally fine.
And I just wanted to say that before we broke.
Yeah, we can say operation status. By the way, one of the questions that Adam had on the operation status API is normally operation status APIs out source consumed and destination written. Because they're always going to be the same for us, is it acceptable to have simply an out int elements process, which is the same for both source and destination?
So why not just have lower in place return the characters process? We've got other span APIs that do that, like UTF-8 parser, which process an input, always return where the cutoff was. And they've replaced and that clearly indicates I've actually replaced everything. I've processed some of the data in here, potentially even having touched it or modified it. And I stopped here. That way there is no bool, there is no operation status for in place.
UTF-8 parser is really meant, my understanding is it's meant for things like CSV scenarios, where you go until you find something like a comma, a space, whatever, and then you stop because you've reached the end of the record. This particular, most people don't imagine text APIs as like being record driven. They imagine them as being like, here's a buffer, I want you to operate on the buffer. That's like, now that I've said that aloud, like maybe that means a partial success API that's not operation status is just weird, given how text APIs historically work.
Right, because my concern here is we're going to return an operation status, and we're always going to have modified value. And so the operation status doesn't really tell anything, doesn't tell the user anything that return value does not equal value.length would.
Right, it's just basically a pattern that's suggesting to you from its shape, do not ignore the return code.
So what we could do then is for the try to whatever APIs, kill the try, just make them 2, and then remove the out int. Like it modifies the entire buffer or it fails.
Yeah, and that would be back to the void. Or if you think that partial success and you want to return an int, that's also fair. You just need to consider how many people are going to call it and ignore the return value.
Yeah, for text APIs, I imagine that'll be everyone.
So as for, whether or not folding the two outs in an operation status, like for the two upper and two lower, makes sense, it doesn't super bother me because I don't think we've before had an operation status for in place. I don't think we've ever had an operation status that was guaranteed to be 1-to-1. But when we do if you do this again for UTF-8, then they can't collapse because you're not guaranteed 1-to-1.
Right.
And so then it's like, is it worth being different here just to save on an out? And I'd probably start with just follow the pattern. And if people complain later, we could add the easier version that only spreads it to 1 instead of 2.
But I found it very confusing when I was using these APIs across BCL, because I was always writing out int elements process and then out underscore, because I didn't care about the second, because I knew that it's going to be the same value. So
does that mean that to upper, if you pass in the same span for source and destination, will behave equivalently to the to upper in place?
This method was originally supposed to throw if there was overlap, but
yeah,
we would need it not to throw in that case.
Yeah, I mean, I think like many of our things, overlaps at 0 could be allowed to work, but overlaps at non-zero is
That'll just be too hard, yeah. Too error prone.
Yeah, so for the short, elements processed versus chars or T's consumed and T's written. I don't have strong feelings other than it's asymmetric to the rest of the operation status pattern. But if we think that everyone understands they're the same and that it's obvious that that's the pattern here, then it's fine with me as a general.
And I would honestly defer to having that slight asymmetry because, like Adam said, it sounds like it's easier at the call sites just to have a single out parameter.
Sure.
And making the consumers happier to me is a little more important than having symmetry.
Yeah.
But I don't know if we've ever formalized that anyway.
We have, like, I don't think we've ever had a case with operation status where it was guaranteed 1-to-1, and this one is. So it is a novel collapse of the pattern. And
like I said, UTF-8 will also just throw a wrench into all of this anyway.
Right, because it has to be.
Yeah, because if it overlaps, woohoo! We just throw our hands up and party.
Yeah, but at least the operation status to upper from char into byte, right? Like that, they're not the same.
Yeah, we don't need to check overlaps. For T and U, where T and U are different, we don't check overlaps.
No. I just mean you can't collapse the two outs because one char could write 4, 5 bytes.
For this, that's not an issue, but yeah.
In UTF-8 dot to upper, the operation status.
Yeah.
So, okay, and then the other note, if you didn't write it down, Emo, was all the needle and haystack APIs. The haystack was always called text, and I think we should probably call it source. But since during the whole review, Levi kept saying it's data that's not guaranteed to be text, we definitely shouldn't call it text.
So source.
Question: why do we have is all ASCII, is ASCII byte, and is ASCII char? Should those not all just have the same name?
I thought it was suggested earlier they were all just is ASCII.
Am I looking at the wrong?
That makes sense.
Scroll to the bottom.
Okay, they are. There's a. Would is valid be a better name? ASCII.isValid instead of ASCII.isASCII?
It makes sense to me, and I don't like names like X is X. Like it just doesn't feel natural.
I could buy that. Yeah, is valid.
Sure.
Yeah, I missed the read-only span overloads because they are smushed up against Git index of first non-ASCII.
Yeah. Sorry. They're in my mind, they're logically the same method group. That's why they're squished there. But yeah, it makes reviewing a little harder.
All right. Anything else that anybody wants to talk about before we call it a day?
Didn't we say equals ignore case should also have the char byte version?
Actually,
And it would
don't.
just forward to the byte chart. Yeah.
It's got 3 of the 4. And I thought we said that the ignore case should have all 4, and we're just going to provide the byte char and char byte for the other ones, the non-ignore case.
That's basically what I wrote here in the notes. Like the API shape that you currently see below is just a repetition of what we had earlier. I haven't changed the API actually at all. Because a lot of the stuff was just general feedback. And it seems to me, I don't think we actually have a proposal for the API right now.
Yeah, we had a lot of hand wave generalizations.
Yep.
Note, it still says text for all those parameters.
Yes. I clarified. All right, let me hit comment. Then I guess we mark it as needs work, and then next Tuesday maybe.
Surprised that people still aren't complaining about the fact that trim returns range.
Well, I guess you haven't looked fast enough or far enough.
Hey, that was a suggestion from last review, so whatever.
It's like we barely made it past equals. No, yeah, I mean, returning range means that you solve the problem for string and read-only span of char and etc. So.
Yep. Okay.
All right, I need
Thank
to
you
run.
for your time,
Bye-bye.
everyone.